What is going on, everybody? Got another video here for you. We're going to do a limit. I've got several of these types on my channel. Check them out if you need to see more examples. But here we have an indeterminate form. If we actually take the limit of this thing as x goes to infinity, this term right here goes to 0 because the denominator is getting larger and larger. And so that goes to 0. And so this in here would just be 1. 1 plus 0 would be 1. And this is going to infinity. So we have 1 raised to the infinity. That's an indeterminate form. And, you know, we cannot say that this is equal to 1. 1 to the infinity. We can't say it's equal to 1. So how do we go about working these? Well, the way we do these is we're going to say let y equal 1 plus 2 over x raised to the 3x. Okay, that's what we're going to let y equal. And then what we're going to do is we're going to take the natural log of both sides. So we got the natural log of y is equal to the natural log of 1 plus 2 over x to the 3x. And then remember, we have a property that says we can take this exponent and pull it in front of the log. So that's going to be 3x natural log 1 plus 2 over x. Now, what do we have here? Well, what the goal is here is we want to end up taking the limit of the natural log of y as x goes to infinity. So you can see if I take this limit here as x goes to infinity, I would get what? I would get infinity times 0, right? Because the natural log of 1 is 0. So we can't do infinity times 0. That's an indeterminate form. So what we want to do is write this as 3 times the natural log of 1 plus 2 over x over 1 over x. All right, that's the same thing. Okay, just think about it. If I took this and I multiplied it back out, okay, if I multiplied this back out, that would be 3 natural log 1 plus 2 over x. See, it's this divided by this, or we can say it's this times the reciprocal of 1 over x. And you can see that would give us 3x natural log 1 plus 2 over x. See, we would get this back. So this is just a different way to write this. All right, so now I think we're ready to take the limit, because I mean, look at this. If we took the limit of this right here as x goes to infinity, this term's going to go to 0. So we got natural log of 1, which is 0. And then as x goes to infinity, this denominator here is getting larger. So this fraction down here is going to 0. So we actually have 0 over 0. And what we're wanting to do is apply L'Hopital's rule. So let's go ahead and take the limit. So the limit, let me write that a little better. The limit as x goes to infinity of natural log y is equal to the limit as x goes to infinity of 3 times natural log 1 plus 2 over x over 1 over x. And as we just talked about a while ago, if I take the limit of this as x goes to 0, I get 0 over 0. So that tells me that I can apply L'Hopital's rule. All right, so I'm going to take the derivative of the numerator. So that's going to be the limit as x goes to infinity of 3 times, okay, so take the limit of this natural log of 1 plus 2 over x, So remember, whatever you're taking the natural log of, that goes in the denominator, and then the derivative of this goes in the numerator. Well, the derivative of 1 is 0, and the derivative of 2 over x is negative 2 over x squared. Okay, so anytime you have 1 over x, 2 over x, 3 over x, some number over x. So let's just go through that. Okay, you have some number over x, and you're going to take the derivative. It's going to be negative that number over x squared. And let me show you how that works. So if we have y over, let's just say k is some constant over x. Well, let's use c instead of k. K looks too much like the x. So we've got some constant over x. Well, to take this derivative, we can rewrite this as y equals c times x to the negative 1. And then if we take the derivative, that's negative c to the times x to the negative 2, bring the negative 1 down, subtract 1, which is negative c over x squared. Okay, I would just remember this. Whenever you have a number over x, it's negative that number over x squared. That's the easiest thing to do. Then you don't have to worry about going through all this and showing that work. All right, so I took the derivative of the numerator, and then I can take the derivative of the denominator. Well, that's negative 1 over x squared. All right. All right, so let's look at this. So now we have the limit as x goes to infinity of, all right, so we're going to write this as negative 6 over 1 plus 2 over x times, whoops, I messed that up. That's negative 6 over x squared. Okay, so I just did the 3 times the negative 2 gives me the negative 6. So I've got this written down. And then, see, divided by this, or we can say times the reciprocal of that. And then what happens here is this x squared and this x squared cancel. And so we're left with the limit as x goes to infinity, and a negative times a negative is a positive. So that's going to be 6 over 1 plus 2 to the x. And then when we take this limit, well, what's going to happen as x goes to infinity, this term right here is going to go to 0. And so we're left with 6 over 1, which is 6. All right. All right. Now we haven't worked the problem because we have to take the limit of this thing. We took the limit of the natural log of that. Okay. So what I've got is I've got the limit as x goes to infinity. Let me make sure I copy it right. 1 plus 2 over x to the 3x. So all I did is I wrote the problem down again. Okay. All right. So this is the same thing as the limit as x goes to infinity of y. See that? Because remember, I let y equal this. So all I did is I replaced this with y. And so this is going to be the limit as x goes to infinity of e to the natural log of y. All right. So I'm just rewriting the y as e to the natural log of y. Now, how does that happen? Well, remember, we have a property that says b raised to the log of x with base b is equal to x. Okay, so if the base of the exponent and the base of the log are the same, your answer is just what you're taking the log of. And the other thing you've got to remember is that the log, let's write it like this, is that the natural log of x is equal to the log of x with base e. See, this ln here, this ln, this natural log, that's just like an abbreviation for log base e. Instead of writing out log base e, we're just abbreviating it as ln. Okay, so you can see what we have is we have e to the natural log of y. That's this term here. And look, this is the same thing as e to the log of y with base e, right? Because ln is log base e. And since this base and the base of the log are the same, see, we're going to this property here, that is just equal to what you're taking the log of, which is y. And see, I just rewrote y as this. Okay. All right. So now, well, look at this. Now I've got the limit as x goes to infinity of e raised to the natural log of y. Okay. Well, what's the limit as x goes to infinity of natural log y? Well, see, we did that right here. That's equal to 6. So this is e to the 6th, and there's your answer. All right, that's a pretty cool problem. I've got a bunch more of these on my channel. Just search my channel. I think probably I would say limits, L'Hopital's rule, or limits indeterminate form, and just look for problems that are similar, that look similar to this one right here, where you've got like 1 to the infinity or 0 to the 0, stuff like that. Okay. All right, well, I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.